Good evening, everyone. So today we are going to build a project with the newly released YOLO V12. So V12 has finally been released, and let's check what outcome can we get if we use the extra large one. So yeah, so the project that I will be building in this video would be the roller hockey. So as you can see, the procedure would be pretty similar to the one used in the kidney stone. Like the dataset will be provided in the description from you can download it either from the RoboFlow or you can have the API link. Okay, so let me show you how the dataset looks like before starting. I guess this is the one. It has like, yeah, 2525 images. Quite a weird name. With augmentation, it has, I guess, yeah, 6053 images, out of which 5292 are the training ones. So it's basically the dataset which have been augmented with these attributes: the flip, crop, and the brightness. Okay, so all you have to do is to click on the download dataset button, then select this option, download dataset, and continue. Now, all you have to do is to show download code and make sure to select the version 12. Alright, click on the continue button and you will receive a API link which you can paste it in your code. So, the code is pretty simple. I have firstly installed the Ultradetix library to import YOLO. Then I have imported some basic libraries. So here you have to copy paste your API link. Okay, so the folder will be downloaded here. Now all you have to do is to initialize your model, create an object or from the YOLO class, specify that we are going to use the 12 extra large version. So the default model will be downloaded. Now we have to initialize our training pipeline. So the YML file that we'll be providing is given here, in which we have to change the train, test, and validation paths. So all you have to do is to click on, like, copy the path of images from the test folder, paste it here. Similarly, all you have to do is to paste it here, but change the text to valid. Similarly, change the path for training as well, and make sure to change it to train. Alright, so the classes we are having is ball, crowd, goal, goalkeeper, player, referee, and stick. Alright, that's all we have to know about the dataset, and we can specify epochs for like 50, 100 or so. You can also specify the patience, but I haven't because this is just a glimpse. I just wanted to see and show what is the performance of the newly launched version 12. So the image size would be 640 cross 640. Batch size I have specified 32. If you have less RAM in your machine, then you should lower this. I am using the A100 A100 NVIDIA Tesla GPU. That's why I have specified the devices to 0, 1. If you do not have a A100, you are using just the T4 GPU, then you can specify it by writing CUDA, or else if you do not have any GPU in your machine, then you should specify CPU. However, it will take much longer time if you are not using CPU. GPU, I'm sorry. Yeah, just a minute. Yeah. So when you click on the run button, the training will be started, and yeah, so it will take some time since it is a quite large data set. So once it is completed, you can initialize the model again with the best.pt file, which is nothing but the weights file, the weights which have been learned throughout the training process. So the model will be initialized with the best weights. Specify the test images folder since we want to get the predictions or detections. So I've specified the images folder. Then in order to predict the predict on the test images, you need to provide the source path, which is test images path. The image size is 640, confidence level is 25%. Like, confidence threshold is nothing but a value above which a model can predict or detect an object. If you increase this value, the detections will be less. If you lower down this value, the detections will be more. So save equal to true, which means we are saving the results in this folder. Device equals to CUDA means I will be using GPU. So there are 260 images on which we are predicting. So after getting the results, we can see it by writing this code slash run slash detect slash predict. So all the predictions or detections will be stored in this folder, and let's see the results. So, oh, my bad. I already saw. So yeah, as you can see, the player has is being detected. The goalkeeper, the crowd, the stick as well is being detected. The goal is being detected as well. As you can see from different, even the puck, the ball is being detected with a confidence threshold of 45%, and the rest is shown. So yeah, I think the model is performing decently well. Let's look at the learning curves. They are present somewhere around here. The results dot cs, no, results dot pg. Yeah. Okay, I should have trained for much more epochs, but it's all right. I mean, we are just testing out. So let's look at the CSV file. So let me set the number of rows to 100. So you can see the specific values like the class loss. I'm looking for, basically I'm looking for this MAPE score, which is 76 and 44. So I definitely would have trained for much more epochs in order to increase the MAPE score and boil down the loss values. But you can set the epochs as you like. Even you can like fine tune this model as well, like tweak around the parameters, perform the hyperparameter tuning, and you will be able to get some better results than this 20. So yeah, that was all. The 12 is really something, and yeah, that's all for this video. Thank you.